All right, so here we go, day 4. We're going back into the mixed and entire radicals. And this time we're going to go the way back on the logic. So last day we did entire to mixed. No, we did mixed to entire last day. So today we'll do entire to mixed, okay? So entire to mixed. Last day we did the other way around. We started it off mixed and went to entire. All right. All right. So did you guys see the list on the whiteboard with all the squares and cubes? So that list is going to help you. So you might want to get that list going on your study sheet. That's why I said I'll get you started. So your study sheet, one page, one side, write as small as possible so you can fit it all in there. And that chart should definitely be the start of your study sheet, okay? So let's take a look at this first one. Converting the square root of 45 into a mixed radical. So let's just recall what these things look like. What does the entire look like? It just looks like that. So is this entire? Yes, it is. And then what's mixed? Mixed is when you have a coefficient out in front. That's not 1. Phelan, you want to get the door? Got a late slip? Okay, that's perfect. Alright, so let's take a look at 45. And then your calculator, you start dividing 45 by certain numbers. Which numbers am I using? Okay, so let me just write something down at the top of this page. Factor into perfect squares or cubes only. So that would be like number 1 step. So when would I do squares and when would I do cubes? Well, it totally depends on what they give you in the question. So for F, what would I use for F? Cubes or squares? Cubes. And for A, I would use squares because of the index of the radical. The index, what's the index for A? Yeah, it's not written, so it's a 2. What's the index for F? 3. So the index tells you what you need to do. Okay, so let's do that now. 45, can it be divided by 4? Is this what you do in your calculator? 45 divided by 4. Does that give you a perfect number? Or a whole number? No. So then you go to the next perfect square. 45 divided by 9. Does that work? Yeah. And then there's only one other thing that you have to worry about. Use the largest perfect square or perfect cube factor. So sometimes the numbers will have more than one perfect square, perfect cube factor. Just use the largest one. So with this, like you could keep trying these. 16's the next, and then 25's the next. Like the numbers will start to get too big, you know, like 25, it's too big, you know. It's not going to go into 45. Okay, so you know it has to be 9. So then what we do is we rewrite 45 as 9 times 5. So you would have tried 45 divided by 9 in your calculator, and it's going to spit out a 5. So those are the two factors. And one of them's perfect. Which one's perfect? The 9. The 9's perfect. What does the 9 go with on the list? See how it goes with 3? So on this list on your whiteboard, the first column is like the length. And for squares, it's like your area. And for cubes, it's like your volume. Okay, squares, cubes, and this is the length. So 3 goes with 9. So what can we do with the square root of 9? We can make it 3. Okay, so what you do here is you split the 9 and the 5. Remember last day we smushed them together? Well, now we're splitting them because we're going the opposite direction. And then root 9 is perfect. It goes with 3. Root 5 is not perfect, so we leave it. All right, so everybody, this is your check. Type in square root 45 into your calculator. What do you get? 6.7, keep going. Dot, 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 right? Is there a pattern to those numbers? Does it stop? It stops on your calculator screen, but not in reality. So what do we call this type of number? Irrational. Now type in 3 root 5 into your calculator. So type 3, then the square root sign, 5. The exact same thing? That's how you know you've done it correctly. That's how you know you've done it correctly. Okay, 75. This one's obvious, 75. What's the perfect factor that factors 75? Yeah, that one's obvious. It's 25 times 3, right? Because, I mean, it ends in 5. So typically if it ends in 5, you should check 25. So we split 75 like this, 25 times 3. The 25, I always put the perfect one first so that it works out nicely like this. Is everybody okay with that? If it's not perfect, leave it. If it's perfect, simplify. So this one this is simplified, and then this one is just left alone. Because the 5 is rational, but this non-perfect root is irrational. So like in math, we don't care about decimals. Personally, we don't care about decimals. So we would always leave it as like a perfect root, like root 3, not perfect, but exact. It's an exact value. There's no approximation. Root 3 is root 3. Okay, 18, what's 18 going to be? Would you use 6 and 3? 6 and 3 factors to 18. Why would I not care about 6 and 3? Because they're what, Jacqueline? Huh? No. Are they on my list? Are they on my chart? No, they're not perfect. So don't use the perfect ones. Would I use 18 and 1? No, that doesn't make any sense. What do you got to use? 9 and 2. And I always put the perfect one first. So square root 9, square root 2. Square root 9 is just 3. How does this feel? Good? All right. Here's the first curveball, 80. So 80 divided by, what's the first one on the list? Yeah, but you're not going to use 0. And you're not going to use 1 because everything divides by 1. So what's the first one on the list? Yeah, 2, but use the area, not the length. So 4. So 80 divided by 4, what do you get there? 20? Okay, so that's a whole number. So I could use 4. But take a look at 20. What's inside 20 as a factor? Could 20 be factored? What's inside 20? Another 4. So maybe there's a bigger one. What's 4 times 4? 16. So try 80 divided by 16. 5. It's this guy here, right? So like when you're doing your check, always check for a bigger one. And square root 80 looks like this. 16 times 5. And the 16 comes out as a 4. Whoops. All right, so like, let's take a look. What would happen if we didn't use 16 and we just used 4? If we used 4, it would be 4 times 20. And the 4 would come out as a 2. So what's the problem here? This one is, I'll change color. This one's not fully simplified. And that's kind of the stuff that I can't really teach you. That's going to be experience. So you might want to always check the leftover, look at 20. Is there any perfect square left in 20? And we already decided, yes, there was. There's another 4 in there. So what could we change 20 to? 4 times 5. Then we split the radicals into the perfect and the non-perfect.
Please excuse this interruption. Mr. Pasqualino and the owner of a gray car parked in the visitor parking. It's a gray car in the visitor parking, and Mr. Pasqualino, please contact the office.
Okay, so then square root 4, what's square root 4? Look on the list. 4 goes with 2. And then you simplify the outside. What's 2 times 2? 4 root 5. So see how you end up at the same spot? You do end up at the same answer, but look how much extra work there was. It's like double the work. How do you avoid doing double the work or simply forgetting to do the extra work? Like a lot of students would probably just leave it right here at 2 root 20. They'd leave it there. What do you always need to do? Use the largest perfect square factor. Okay? All right, so now we're into cubes. So now it's a different list than the squares. Oh, I missed 98. Thank you. 98's a weird one. Take out your calculator. 98 divided by 4. Oh, why you gotta do that? So you guys need a surefire method. So everybody needs a calculator in their hand. Who doesn't have a calculator in their hand and needs one? Everybody's got one? Okay, in your calculator, 98 divided by 4. Do it, quick. 98 divided by 4. Do you get a whole number? So if you don't get a whole number, go to the next one. 98 divided by 9. Not a whole number? Keep going. 98 divided by 16, then 98 divided by 25, then 98 divided by 36. You're just trying to factor out a perfect square, which means divide. So divide perfect squares till you get whole number. 49. So you arrive at 49. What's the calculator give you as the other factor? 2. How does the 49 simplify? 49 on the list goes with 7. So if you have your list next to you during your homework and your test, you're going to have success. If you don't have this list, and maybe you got it memorized, like there's probably a few people in this room that definitely could go without the list and still have success. But in general, use a list. All right. And in past years, like I've made students memorize the list or jot down the list, like right at the beginning of the test. If you have the graphing calculator, then you can just use the table So it's for free, and if you forget that, I'll show you. Okay, cubes. What are the cubes on the list? 1. What's the next one? 8. Next one? 27, 64. So they get big pretty fast. So the cubes are actually easier because you don't need to check that many. So check 8. 8's always the first one you check. Does 8 divide 32? It goes with 4. So I'm just going to split the factors in the first step because I think most people are getting this. 8 times 4 is 32, so we just split the radical. And then the perfect one will simplify to what goes with 8 in this list. What's on the same row as 8? Yeah, but you're not going to go to the area, you're going to go to the length. So it goes to 2. And cube root 4 is non-perfect, so leave that. So it's identical form. Do you guys see how it's identical form? Here, I'll circle this. It's identical. You have a coefficient that's not 1, and then you have a radical. That's not perfect. The only thing that's different is the index. The index for this one's a 2, the index for this one's a 3. That's the only thing that's different, is the index. Okay, the next one, 250. And this one's obvious because it ends in a 0. So the one that goes with 5. What's the one that goes with 5? 125. So this would be 125 and 2. So we need the cube root of 125 times the cube root of 2. Simplify the perfect one. Cube root of 125 is 5. 5 times the cube root of 2. And notice how I write the index. Is the index the same size, like font? Some students will write things like this. Like, what the heck? Is that 53 or is that 5 cube root 2? So be very organized with your notes and your solutions, okay? And then these ones you're not going to see in Math 10C, but I'll still show you them. Here, let me just do something on the side here to remind you. So let's pick actually, whatever. I don't think that's going to help. Okay, let's just try this. So we have numbers and we have coefficients. Or not coefficients, we don't want to use that word. We have numbers and we have terms. Okay, here's your number, and then here's some variables. Okay? Let's just do the 20 first. What do we know 20 would be? Like, you have choices, right? Should I use 10 times 2? Is that going to help us? No, those aren't perfect. What's a perfect square that divides 20? 4 and 5. Okay, so split it up. Square root 4, square root 5. And then let's split the variables. Okay, so how many of these are perfect? Is square root 4 perfect? What would that become? 2. Is square root 5 perfect? No, so leave that. Now let's take a look at these variables. Is a squared perfect? Yes. Why? Yes, square root. So do those kind of just undo each other? So what would the answer to that one be? A. All right. Let's just sort of leave that. Let's try the next one. B4. What would make B4? Think about what's the power on A right now? What's the power on A right now? No, right now. What is the power on A right now? A1. So how do you go from 2 to 1? You divide by 2. So what do you think the answer to the next one's going to be? B2. Let's think about this shape. Say you had a square of area B4. What are the lengths going to be? Yeah, 2 and 2. Do you guys remember some of those exponent laws from grade 9? So in order to get the area, what do you have to times? The length and the width. So what's B2 times B2? B4. You would add those. Do you remember that? So with powers, we'll come to realize that powers and roots are closely related. In fact, they're the same thing, but we'll get to that. So what you need to make a note of is even powers on variables are perfect. Okay, even powers on variables are perfect. So if I had like B5, would that work? No. But that's more 20-1, so we're not going to really focus on that too much. And then let's clean this answer up. It's going to be 2ab squared root 5. There's, oops, undo. There's the answer. So this next one, let's just work on the number. What could 50 become? That one's pretty easy, 25 times 2. So then you want to split them with radicals. What's the square root of 25? 5. Okay. So we also have the square root of a squared and the square root of b squared. What's going to be the answer to those? A, b. And the only one that's not perfect was the root 2. So it's 5ab root 2. And this thing that I highlighted, even powers on variables are perfect, that's only for the square root. Because what's the index for the square root? What's the index? 2. So like when you go to cube roots, the only powers that are perfect for cube roots are the powers that are divisible by 3. So, but don't worry too much about that. We're not gonna spend, I don't think, much time at all on the variables. That's more of the course next year. All right, next page. What does it mean to fully simplify a radical? The radicand has no perfect square or perfect cube, depending what the index is. Factors left over. Or not left over, but like left inside the number, if you will. So this one here, 4 times square root 20. Is that one completely done? Or is there a perfect square factor inside 20? There's a 4 in there, right? 20 is 4 times 5. So let's rewrite this thing. You got the 4 on the outside, and then square root 20 would be the same thing as square root 4 times square root 5. I just rewrote 20. Square root 20 becomes square root 4, square root 5. That's the only thing that changed. Does everybody see that? Look at the board. Did everybody see that? What did I do? I changed the square root 20. Okay, so I'm going to undo that so it's not messy. Now which one of those is perfect? The root 4. Root 4 becomes? It becomes 2. And root 5 is still root 5. What do I do with this 4.2? Simplify it to 8. Alright, so let's take a look at the next one. 3 is just 3, right? We already did 50. What did 50 become? Root 25 and root 2. The root 25 would simplify to 5. So what's that number on the outside? 3 times 5 is 15 root 2. So there's your answer. Okay, next one. 5 is just 5. What about 12? 12 is an easy one. Good. 4 times 3. The 4 comes out as a 2. 5 times 2 is 10. Uh-oh, next one is different list. So we're not using the squares anymore. So now we're going to use the cubes. So here's the first few cubes. You think 8 works? Try 8. Does 54 divide by 8? No. Does 27 divide by 54 divided by 27? What do you get? 2. So 27 and 2. Those are cube roots this time, not square roots. And what do I do with that 2 on the outside? Just bring it down. It's all good. Just bring it down. Bring down that 2. Simplify the perfect one. What does 27 go to on the list? 3, because 1, 2, 3, 4, and so on. Right? So this one becomes a 3. And cube root 2 is not perfect, so leave it. Simplify the left side. 6 cube root 2. Is it easy? It is fairly easy once you do a few. Now the problem is we're going to spend like the whole rest of this week doing exponents and exponent laws, and you're going to forget about radicals. Okay, so that's why today I want an up-to-date study sheet with the radicals, everything else that's on that board. Those LCM GCF strategies with the L shape and the out to the left Beyonce thing, remember those? So make sure that's on your study sheet. Make sure you have perfect square, perfect cube notes and irrationals and real number notes. Remember those charts? Quiz 1. And then mixed to entire. And then the whole rest of the unit is exponent laws, the last thing on the whiteboard there. Is that it? Okay, so here's your homework, page 218. And don't forget about that worksheet I gave out on Friday. You got to do part B this time. Yep. Kiki's got it in her hand. Yep. Yep.